So our next speakers are going to be talking on a subject quite closely aligned. They're looking at how you can optimize federated learning hyperparameters more widely, and they've invented a system for doing just that. They've also flown all the way from South Korea, which we're very appreciative of. I'll start off with we have Professor KangYoon Lee and SeMo Yang, and they're going to be talking to us about a system called FedOps, Federated Learning Lifestyle Operation Management, which has been built to work well with Flower. And so with that, over to our speakers.
Great, thanks for giving me a chance to presentation. And FedOps come from Federated Learning MLOps. So this slide is for like machine learning operations and so on. So I'm run the cognitive computing lab in Gachon University as in Korea. And we will cover what is FedOps and the motivations. And also we have implemented on micro Kubernetes and the virtual devices, the heterogeneity simulations. So we will explain on that. And then we will learn on real devices. And those are cross silo implementations. And we have GitHub and installations. So we will show the demo to you. And then we will explain about our future works. And then very brief cognitive computing lab is FedOps is one of focus items. And also we do multimodality to get biomedical information through the sensors, and then kind of expectation analysis and so on. And then focus on IoT, CPS, digital twin models. So medical twins, and then get the real world data and analytics and so on. And today we are focused on FedOps. FedOps is the SeMo Yang is a leader in my lab and master students, and he will explain all of this. Okay.
Yes. So I will introduce our FedOps platform in detail. So we developed FedOps to address the lack of practical research in operating and managing federated learning in real-world projects. Federated learning algorithms and frameworks show promise in enhancing performance, but an effective FL operations platform is required. So to provide a solution, we focused on three key questions. First, easy application of AI machine learning in federated learning. Second, deployment and execution of data and models in multiple clients. Third, managing the FL lifecycle in real-world scenarios. In the overview of FedOps, we extended the existing MLOps to facilitate the application of federated learning to machine learning projects. The baseline model created through MLOps is deployed and executed to multiple clients that configured to perform federated learning by connecting to the server. And the local global model is continuously version managed. And to manage and monitor the FL lifecycle, FedOps enables the tracking of logs from both the client and server, ensuring smooth federated learning operations. So FedOps has 5 key features. First, FL Scalelize. It simplifies the application of data and models in a federated learning environment by leveraging Flower's client and server. Second, the manager oversees and manages the real-time federated learning progress of both client and server. Third, contribution evaluation and client selection processes incentivize individual clients through a BCFL based on their performance. First, the CI/CD CFL system integrates with a code repository, enabling code deployment to multiple clients and servers for continuous or periodic fast running. Fifth, the FL dashboard is available for monitoring and observing the lifecycle of FL clients and server. We have summarized the distinctive features of FedOps by conducting practical tests on various FL frameworks. FedOps allows users to easily apply their own data and models without caring about fast running. And FedOps has manager components that continuously manages the status of client and server. Only FedOps has this feature. And FedOps supports both system and data heterogeneity simulation capabilities and provides CI/CD CFL functionality to multi-client. So FedOps can manage the lifecycle of clients and server with these functions. And FedOps enables FL simulation in the cloud. We conducted FL simulation with Micro Kubernetes, our cloud environment. First, developer links code repository to CI/CD CFL system, and multiple client paths are set up using the open source tool ROCD, which supports CI/CD. Additionally, it is utilized to deploy the server manager, and the CFL system continuously deploys and runs FL server using Airflow. This enables the execution of FL between clients and server using manager components, and incorporates a function to enhance FL performance through CECS based on their performance. And FedOps stores and manages local and global models based on versions. It also provides monitoring of the entire FL process for FL lifecycle management. FL simulation with system and data heterogeneity is visible on Micro Kubernetes. By leveraging ROCD, it is possible to continuously deploy and run the client paths with varying system resources and data. And multiple FL tasks can be created using Airflow, and FL servers can be deployed and executed for each task to facilitate the various FL tasks. During the execution of FL, it is possible to monitor the performance metrics such as accuracy and loss of the local and global models. Additionally, the status of time, cost, and data for both client and server can be tracked and monitored using ERK stack. And we developed a FedOps web service to manage the lifecycle operations of FL on real devices. Users can create FL tasks and register task ID in the client. Once the user selects the client that participates in the FL round, the user can run FL task and that deploys FL server. As FL is performed, the user monitors local and global model performances and manage and download global model through the web interface. At the client level, the client can monitor own data and performance with WNB and ERK. We have open sourced FedOps, and it can be easily installed from PIP. The guide includes the Git repository address and instructions for managing the lifecycle of your FL tasks. But while the web service for FedOps is currently available, it will be deployed in the near future, allowing you to utilize our FedOps platform for your fast-running operations. I will demonstrate a FedOps demo that showcases the management of FL lifecycle using a real device. Okay. To get started, create your FL task in the FedOps web interface. Enter the title, description, and tags for your task. Additionally, provide the address of the FL server key repository that you have created. Once registered, it is not cumbersome to upload the code file to the web because you can separately manage the FL server code only in Git. This allows the FL server to be deployed and run in our server environment. Once your FL task is created, it will be assigned a unique task ID. In order to register a client in this FL task, the client's config file needs to be updated with the assigned task ID. And the user's WNDB information for client monitoring and run the client and client manager. In this way, the client is registered in the FL task. Yes. After selecting the client, click the FL Start button. This deploy and execute the FL server code that you previously set up in the server repository. The FL server creates FL launch for task. So the client proceeds with training as much as the round set in the server. And FedOps provides lifecycle management for FL tasks. You can monitor the performance of the global and local models and track the client system resource usage based on the model version. And to monitor, additionally, you can save and manage the global models according to different versions. And to monitor the performance of the client's local model and the status of the client's data, you can check the information using the WNDB that you set up earlier. This demo specifically demonstrates the train of a TensorFlow based on CNN model using the Cypher10 data set. If you configure the data loader to import data in real time, there are advantages that enable continuous fast running without worrying about client and server interactions. And FedOps also supports a Docker-based client environment, and clients can monitor their data and performance through the ELK stack. To conclude, our FedOps ensured efficient management of FL tasks from start to finish. FedOps FL simulation replicates real-world scenarios by incorporating diverse data and systems. And lastly, web service enabled FedOps platform empowers FL management on real devices. In our future work, we have several goals. First, we plan to support mobile devices, expanding the reach of our platform, and want to incentivize participants in fast running to drive performance and engagement. And we will leverage the power of FedOps for decentralized clinical trials and distributed telemedicine. By achieving these goals, we aim to enhance the reliability and accessibility and effectiveness of our platform. So we wrote 2 papers about FedOps. First, FSKLite has recently been published in the IEEE Access Journal. The paper provides a detailed and comprehensive description of FedOps. And we conducted an analysis on system heterogeneity and assert a thesis on CCS, which is currently under review. Also, we wrote an article on privacy-preserving personal identification using fast learning and non-contact radar signals with the Flower framework. Okay, thank you for your attention. Yeah.
That's great. Thank you so much for the talk.
Yeah.
And I'm wonderful. It's wonderful to know that the intention is to open source this framework so all the Flower users can try it out.
Yeah.
Perfect.
Okay, yeah.
Any questions from the audience or online? I had one question, and that was what's the most difficult kind of thorny issue when it comes to FedOps? Do you think that this platform can help people solve? There's sort of like, what's a difficult optimization problem people commonly have to do, and that this tool can help them with? The worst one.
Yeah.
뭐이 어려운 점이에요?
It is difficult to connect distributed client and server because portfolio issue with our cloud environment. So it is so difficult in connection client and servers.
Oh, I see.
Yeah.
Yeah, I mean, I think Federated Learning manages to find the worst of machine learning,
Yeah.
optimization, and the worst of distributed systems and kind of stick them together. So to make something magical. Any other questions? No? Okay, well then I think the community really looks forward to using this platform. So thank you so much.
Yeah, thank you.